students, welcome to Vidya Myriad. This video is made for class 9 on chapter number 10 circles, and today we are going to begin with exercise 10.4. Let's begin the exercise with the theorems related with this. So theorem 10.6 states that equal chords of a circle are equidistant from the center. Now if you look at this figure, we have two equal chords AB and CD. They are equal. Now here we are going to draw the perpendiculars OX and OY, which means that will be 90 degrees. We need to prove that this OX and OY, they should be equal. They are equidistant from the center. Let us prove it. Now since AB is equal to CD, it's given to us. So half of AB and half of CD will also be equal, which means AX will be equal to CY. We have already done this. On what basis we are saying that it will be half of AB and half of CD will be equal? Because the perpendicular which we draw from the center of the circle, it bisects the chord. It means if I take the chord AB, that AX will be equal to XB, and if I take the chord CD, CY will be equal to YD. So on this basis we can say that AX is equal to CY. Now let us take the two triangles AOX and COY. The shaded yellow part, we will focus only there. We know OA and OC, they are the radius of the circle. Now AX and CY, they are equal. We have just proved above. And angle OXA is equal to angle OYC because they are perpendicular 90 degrees. So we can say that these triangles are congruent by RHS because we have a right angle here, we have the hypotenuse here, and we have the side here. So therefore we can say that OX is equal to OY by CPCT. Now we have theorem 10.7 also, which states that if the chords are equidistant from the center of the circle, they are equal in length. That means we are given that OX is equal to OY. We need to prove it. AB is equal to CD. Let's do it with the help of two triangles. Now in these two triangles, we know OA and OC, they are the radius of the circle. We know OX is equal to OY. There it is given to us because they are equidistant from the center. And angle OXA is equal to OYC because they are perpendicular, so 90 degrees. By RHS criteria, triangles are congruent. And when the triangles are congruent, we can say that AX is equal to DY. Now, we need to prove it. AB is equal to CD. For that, we know that OX is perpendicular to AB and OY is perpendicular to CD, and we know that the perpendiculars which are drawn from the center of the circle to the chord bisects the chord. What does it mean? AX will be equal to XB and CY will be equal to YD, and we can say that AX is equal to XB, which means AB is equal to twice of AX, CY is equal to YD, which means CD is equal to twice of DY. So from this equation, AX is equal to DY means if we do twice of AX is equal to twice of DY, it means AB is equal to CD, and hence we prove that chords are equal. Now based on these two theorems, we are going to do the exercise. Question number 1. Two circles of radii 5 cm and 3 cm intersect at 2 points, and the distance between their center is 4 centimeters. Find the length of the common chord. Now if you look into the diagram, there are two circles. We have P and Q which are intersecting the two circles. Okay. We know that OP is 5 centimeters and PS is equal to 3 centimeters. We also know that OS is equal to 4 centimeters. Now from there, let us assume that let RS be X, so OR will be 4 minus X. Based on this information, we are going to use Pythagoras theorem to find out the length of the common chord. So if I take the triangle POR, the red line, just concentrate here. We have OP, we have OR, we don't know PR, we need to find out. So what does it mean? Hypotenuse square is equal to perpendicular square plus base square. What is hypotenuse? OP square, which is 5 square. What is perpendicular square? OR the square, which is 4 minus x the whole square. What is base? PR. So PR square. Using this information, we will find out the value of PR. Now here OR is given to us as 4 minus x the whole square. Using formula of a minus b the whole square, we will put a square minus 2ab plus b square. Just use this, you will get 25 is equal to 16 minus 8x plus x square plus PR square. Now we need PR, value of PR. So what we are going to do is, we will keep PR on one side and put other things on the other side. So we get PR square is equal to 9 minus x square plus 8x, or you can write it as minus x square plus 8x plus 9. Let it be equation number 1. Now let us take the another triangle PRS. Now in this we know PS is the hypotenuse, so PS square. My perpendicular is RS square, which is x square, and my base is PR square. Now PS 3 square is 9 is equal to x square is plus PR square. So what is PR square? 9 minus x square. Let it be equation number 2. Now if you look at equation number 1 and equation number 2, your both the equations are with PR square. So we can write it 9 minus x square plus 8x is equal to 9 minus x square. Both get cancelled. So 8x is equal to 0, x is equal to 0. Now we need to find out the value of PR. So let it put the value of x in the equation number 2. My PR square is equal to 9 minus x square. X is my 0. So PR square is 9. So what is my PR? PR is equal to 3 centimeters. So if I know PR, I know PQ. PQ is equal to 2 into 3, which is equal to 6 centimeters, because it divides equally into half. So the length of PQ, or the common chord, is 6 centimeters. Question number 2. If two equal chords of a circle intersect within the circle, prove that the segments of one chord are equal to the corresponding segments of the other chord. Understand this question. Here we are given the two equal chords, that is AB is equal to CD. We need to prove that AE should be equal to DE and CE is equal to BE. Now for that, let us do the construction by drawing the perpendiculars OM and ON, and we will join OE. Now here, since we have AB is equal to CD, we know equal chords are equidistant from the center. So we can say that OM is equal to ON. And we also know that OM and ON are perpendiculars to the chords. So we know that perpendicular, they will divide it into equal halves. So that means AB is equal to AM is equal to MB. So that is dividing into half. That means AM is equal to half of AB. Similarly, if we take DC as a chord and ON as a perpendicular, it will bisect into two equal halves, which means DN will be equal to NC, which will be equal to half of CD, because of the theorem 10.3. Based on this information, we will try to make two triangles congruent. Now let us take the two triangles looking into the figure OME and triangle ONE. In this, OME is equal to ONE, which is equal to 90 degrees. OM is equal to ON, which we have just proved above. They are the equal distant chords. So OE is equal to OE, which is common. So by RHS criteria, we can say that triangles are congruent. And when the triangles are congruent, we can say that ME is equal to NE. Now using this information, CPCT, what we have done is, I have added AM on both the sides. Now when I do that, AM plus ME is equal to AM plus NE. Now NE and AM are not related. So what I will do is, I will just find out their relation. What is their relation? We know AB is equal to CD. We also know that AM is equal to ME and CN is equal to ND. That means half of AM will be equal to half of DC. That means AM is equal to DN. So we can say that we will substitute this in my right hand side, because now if you see AM plus ME becomes AE. AM plus NE is nothing. So I will substitute AM with DN. So DN plus NE gives you DE. So I proved that AE is equal to DE. Now we know that AB and CD are equal. Just subtract AE and DE from them. You will get BE is equal to CE, which is your remaining part, and hence we have proved both the things. AE is equal to DE and CE is equal to BE. Question number 3. If two equal chords of a circle intersect within the circle, prove that the line joining the point of intersection to the center make equal angles with the chords. So what does it mean? What I have to do now? We are given AB is equal to CD. We need to prove that the line which is joining, that is OE, is joining the intersecting of AB and CD. They are making equal angles, which means angle OEA is equal to angle OED. So for this I have drawn a construction OM and ON as perpendicular, and using two triangles OME and triangle ONE we will make it congruent. Now OM is equal to ON because chords are equidistant from the center, we know that. Now OE is equal to OE, that is common also and it is hypotenuse also, and angle OME is equal to angle ONE, that is the right angle 90 degrees. So we can say that triangles are congruent by RHS, and by CPCT we can say that OME is equal to angle OEN or angle OEA is equal to angle OED. Question number 4. If a line intersects two concentric circles with the same center, with center O at A, B, C and D, prove that AB is equal to CD. Now this is the figure. OM is perpendicular to line L, okay, and there are A, B, C, D on the circles. There is an outer circle and there is an inner circle. If I look at the outer circle or a bigger circle, you see that OM is perpendicular to L, which means that AM is equal to MD. We know that perpendiculars from the center to the chord bisects the chord. Similarly, look at the inner circle. OM is perpendicular to L, so I can say that BM is equal to MC. Perpendiculars from the center to the chord bisects the chord. Now subtract from bigger to smaller. So I can do AM minus BM. If you see, your leftover is AB. MD minus MC, if I do, my leftover is CD. And hence I have proved that AB is equal to CD. Question number 5. There are three girls, Reshma with R, Salma with S, Mandeep with M. They are playing a game by standing on a circle of radius 5 meters drawn in a park. Now Reshma throws a ball to Salma and Salma to Mandeep, Mandeep to Reshma. If the distance between Reshma and Salma and between Salma and Mandeep is 6 meters each, what is the distance between Reshma and Mandeep? Let us look at the figure. So I have drawn it, I have put all the measurements over here, and since we know that RS and SM, they are equal, both are 6 meters, we know that angle 1 will be equal to angle 2, which means equal chords of a circle subtend equal angles at the center. So that means angle 1 is equal to angle 2. You need to remember this. If you have equal chords, they will subtend equal angles at the center of the circle, that is O, which means angle 1 is equal to angle 2. Now taking care of this, there are two small triangles. If you see red line with yellow filling, we will take these two triangles and make them congruent. Now let us take triangle POR and POM. In this we have already said angle 1 is equal to angle 2 because equal chords of a circle subtend equal angles at the center. We know OP is equal to OP, which is common. We know OR is equal to OM, that is the radius of the circle 5 meters. So the triangles are congruent by SAS. And when the triangles are congruent, we can say that PR is equal to PM. And angle OPR is equal to angle OPM. If you look at these angles, they form a linear pair. Linear pair sum is 180 degrees. Since they are equal, we can say that they are 90 degrees and hence OP is perpendicular to RM. Now let us take two big triangles, red part if you see, RSP and MSP. Taking this into consideration, we have RS is equal to MS 6 meters. Okay. SP is equal to SP, it's common, and PR is equal to PM, we have just proved above. By SSS criteria, triangles are congruent. And when the triangles are congruent, we have proved that angle RPS is equal to angle MPS. But both form a linear pair, both are equal, that means angle forms is 90 degree, which clearly means that SP will pass through O. Okay. Looking into this information, let us assume now what is OP, what is SO, and taking care of this, we will solve next part. Now take the triangle. Now what we will do is, we need to find out what is RP. For finding RP, what I have done is, I will solve the Pythagoras theorem, two simultaneous triangles. Let me take first triangle OPR. Using the Pythagoras theorem, I know that OP square plus RP square is equal to OR square. So RP square comes out to be 5 square minus X square. Similarly, let me take a next simultaneous triangle, that is SPR, the yellow shaded part. Now here if I calculate, it is 5 minus X the whole square plus RP square is equal to 6 square. Now RP square is equal to 6 square minus 5 minus X the whole square. Now if you look both the equations, RP is equal to 5 square minus X square and 6 square minus 5 minus X the whole square. Equate them together, you will get your X as 1.4. Now remember that SO is also the radius of the circle. Okay, when you know the radius of the circle, that will be also 5 centimeters. That is why we have taken the SP as 5 minus X, because OP taken was X. So remember that. Now we need to find out the value of X. RP square is equal to 5 square minus X square. RP will be equal to 4.8 when you solve it. So RM will be twice of RP, which is equal to 9.6 meters. Question number 6. A circular park of radius 20 meters is situated in a colony. Three boys, Ankush, Syed and David, are sitting at an equal distance on its boundary, each having a toy telephone in his hand to talk with each other. Find the length of the string of each phone. Now if you see the diagram, ASD is the diagram. This is an equilateral triangle and we are assuming let the sides be 2x and AM is perpendicular to SD. Now, since it is an equilateral triangle, AM passes through center O. So, SM, if I take it, SM will be half of SD, because if it is perpendicular, it will bisect the chord SD. That means SM will be equal to MD. If SD is 2x, SM will be x. Using this information, we will find out the big triangle ASM. Using that, we know what is AM. Now AM square plus SM square will be equal to AS square using Pythagoras theorem. We know what is AS, we know what is SM. So AM comes out to be root 3x meters. Similarly, let's take OM is equal to AM minus OA. So which will be root 3x minus 20. Now if I take triangle OSM, I know OS, I know SM, I know OM. So based on this, I will find out the values. OS square is equal to SM square plus OM square, which means 20 square is equal to x square plus root 3x minus 20 the whole square, which is 400 is equal to, solve it, you will get x as 10 root 3m. So SM is x. So what will be SD? Twice 2x. So 2 into 10 root 3, which comes out to be 20 root 3m. So length of the string comes out to be 20 root 3 meters. With this we finish exercise 10.4. There are so many theorems. Use it, do it slowly, systematically, and try to make the two triangles congruent, and using that simultaneously you can find out the values of x or pr or whatever is common in between them. And very soon I am going to come with next exercise 10.5. Till then, see you children. Take